topic is bijective function and related problems. Bijective functions and related problems. Okay, let us start. Topic is bijective functions. Topic is bijective function. What is mean by bijective function? A function f from x to y is said to be bijective if f is both 1, 1 and onto. A function f from x to y is said to be bijective if f is both 1, 1 and onto. Now consider an example for bijective function. Now consider an example for bijective function. The function, consider an arrow diagram f from x to y. Here x consists of 1, 2, 3 and y consists of a, b, c. Here elements of x have distinct images in y. Distinct element of x have distinct images in y. Also, every element of y have a pre-image in x. Every element of y have a pre-image in x. Then we say that this arrow diagram is a bijective function. That means 1, 1 and onto. This function is 1, 1 and onto or bijective function. Clear? Next, note that if x and y are any two finite sets, x and y are any two finite set having the same number of elements, say n, then the number of bijective functions from x to y is n factorial. Then the number of bijective function from x to y is n factorial. Once more, if x and y are any two finite sets having the same number of elements, say n, then the number of bijective functions from x to y is n factorial. For example, if A and B are two non-empty sets, both consist of 3 elements. Okay, then we know that here n of A equal to, that means number of A equal to 3 and n of B, that is number of B is equal to 3. Okay, therefore the number of bijective function, number of bijective functions f from A to B is equal to 3 factorial, that is equal to 1 into 2 into 3. 3 factorial is 1 into 2 into 3, that is equal to 6. Therefore number of bijective function f from A to B is 6. Clear? Problem is, show that the function f from n to n given by f of x is equal to 2x is not a bijective function. Once more, show that the function f from set of natural number to natural number given by f of x is equal to 2x is not a bijective function. Here you want to show that the function f of x is equal to 2x, the function is from f from n to n, is not a bijective function. Okay? Here the function is f of x is equal to 2x. We want to show that f of x is equal to 2x, f from n to n is not a bijective function. We know that if function f is bijective, then it is 1, 1 and onto. Then f is both 1, 1 and onto. Okay, first we check is this function is 1, 1. Is this function is 1, 1. Okay, for that we have to show that if a function is 1, 1, we have to show that if f of x1 equal to f of x2, that implies x1 equal to x2. If f of x1 is equal to f of x2, that implies x1 equal to x2. Okay, if a function is 1, 1, then we say that f of x1 is equal to f of x2, that implies x1 is equal to x2. Here f of x is equal to 2x, then f of x1 is equal to 2x1. Okay, and f of x2 is equal to 2x2. Okay, then if f of x1 is equal to f of x2, that is 2x1 equal to 2x2, that implies here 2 get cancelled, we get x1 equal to x2. That is f of x1 is equal to f of x2, that implies x1 is equal to x2. Then we say that The given function f of x is equal to 2x. F from n to n is 1, 1. This is a 1, 1 function. Okay. And we say that this function is 1, 1. Okay. Which we want to check is this function is onto. Is this function is onto. Okay. We know that if a function is onto, then every element of y have a pre-image in x. If a function is onto, every element of y have a pre-image in x. Okay. Here f of x is equal to, here f of x is equal to 2x. That means y is equal to 2x. Here x comma y belongs to capital N. That is set of natural numbers. X and y belongs to capital N. Note that. Okay. X comma y belongs to where? Capital N. Set of natural numbers. Then from this we write x is equal to y by 2. We write x is equal to y by 2. Okay. Consider if y is equal to 3. If y is equal to 3, we get 3 by 2. That is equal to 1.5, which does not belongs to capital N. Which does not belongs to capital N. Okay. Then we say that this function is not onto. Then we say that this function is not onto. Then we conclude that this function is 1, 1 but not onto. This function is 1, 1 but not onto. That means this function is not a bijective function. This function is not a bijective function. Okay. Next problem is, show that the function f from R to R given by f of x is equal to 2x is bijective. Listen. Show that the function f from R to R, the set of real numbers to set of real number. Function is from set of real numbers to real number given by f of x is equal to 2x is bijective. We want to show that f of x is equal to 2x is bijective. Okay. The function is from R to R. Given that f of x is equal to 2x, f from R to R, we want to show that this function is bijective. For that, we want to show that f is both 1, 1 and onto. A function is bijective, then f is both 1, 1 and onto. Okay, so we first check the function is 1, 1. First we check is this function is 1, 1. We know that a function is 1, 1, then f of x1 is equal to f of x2, that implies x1 is equal to x2. Here f of x is equal to 2x and f of x1 is equal to 2x1 and f of x2 is equal to 2x2. Okay. Then f of x1 is equal to f of x2, that is 2x1 is equal to 2x2. That implies 2 get cancelled, we get x1 is equal to x2. That means if f of x1 is equal to f of x2, that implies x1 is equal to x2. Then we say that this function, the given function is 1, 1 function. This is a 1, 1 function. Next we have to check is this function is onto. Is this function is onto. Here f of x is equal to, here f of x is equal to 2x. That is equal to, that implies y equal to 2x, comma, x comma y belongs to capital R. Okay, x and y belongs to set of real numbers. Now from this we write x is equal to y by 2, which belongs to R. Because if we take y is equal to 3, we get 3 by 2, that is 1.5, which belongs to R. If we take 2.5 divided by 2 is also a real number. Therefore we get x is belongs to R. Okay. Then we say that this function is onto. This function is onto function. From that we conclude that the function is 1, 1 and onto. So the given function is bijective. The given function is bijective. Okay.